It's just basically going to go over how we construct the nets for pyramids. And I'm featuring at the beginning of this video a picture of the Louvre pyramid, which is actually made up entirely of glass and is built as an entrance to the Louvre Museum in Paris. A couple of interesting pieces of information about the Louvre. It is designed by I.M. Pei, who's an architect from China, and it caused a lot of, I guess, drama when it was first built. The purpose of it being built was to make a larger entrance to the most famous and most popular museum in the world, which this accomplished because it created a new entrance that would allow people to go to all three levels of the museum. But it did create a lot of anger and frustration with traditionalists in France because they felt like it didn't match what else there was. But it's actually the probably the second most recognizable aspect of France behind the Eiffel Tower, and I spelled it for you here. So if you wanted to look it up and find out more about it, it's actually pretty amazing and is definitely on my bucket list to eventually get to see at some point in my life. But it's pretty special. I bring it up because we're going to be talking about nets today on pyramids, and so we worked quite a bit with prisms the last 2 days, and we're going to be working with pyramids and trying to decide how to build the net. But honestly, if you wanted to find out how much glass it would take to build this pyramid, which by the way is 71 feet high and 115 feet across, you actually would have to find the area of each of those lateral faces. And you can see by the shape of its base that this is a square pyramid. So this is obviously not the exact same thing, but what I have here is an example of a net for a square pyramid. And you can see I made this out of corrugated cardboard so that I could fold it up, and you can actually see it build itself. And so you can see right there that that would be a net of a pyramid. So if I wanted to find out the surface area of the Louvre pyramid, I need to find the area of this space, this space, this space, and this space. Now, because the pyramid doesn't have a glass floor, that's the entrance to the museum, you wouldn't find that. But for our purposes, since we will be finding the surface area of pyramids this week, you would need to find the area of every part in order to find the surface area of the entire figure. So with this particular shape, this square pyramid, you'll notice that it has 4 lateral faces that are triangular and then 1 square base. And that same concept would be applied with a triangular pyramid, except that it would have a triangular base and then it would just have 3 lateral faces. I'm going to, with you today, draw several nets for pyramids, and I will say pyramids are very easy to draw a net for, and you might find yourself wanting to give it a try. Try drawing your own triangular base and then make 3 triangles and then cut it out and see see that you can create your own pyramid. You could do it with a rectangle just as easily. It's kind of like a star shape if you think about it. So we'll take a look at a couple of those. But first, let's just kind of take a little housekeeping here. If you'll recall, when we started our lesson on prisms, we kind of had a worksheet similar to this, where it wants us to label the faces as either a base or as a lateral face. All right, and you can see right here that this is referring to the bottom of the pyramid, and that would then be our base. And you can see that that's a rectangular base. All right, and then you can see that this is pointing to this face here, and this would be a lateral face. And so we know that bases are also faces, but with a pyramid, we learned that all the lateral faces would be triangular, and then the bases would determine what type of pyramid this is. So since our base is a rectangle, we would call this a rectangular pyramid. Now, I know some of you, when you look at that, you might say, well, Mr. G, that looks like that could be a square pyramid. You're right. It could be a square pyramid. But because I don't have labels on here, and nothing in the directions indicated that this was a square, I don't know for sure that it is. That perspective's a little skewed because it's not drawn to scale. So, and it's not labeled with any dimensions. But I can't go wrong calling it a rectangular pyramid, so that's what I'm going to go ahead and call it. So now we're going to take a look here. We've got another pyramid, and again, we're asked to identify the base and the face and the lateral face. And you can see, our base we typically have on the bottom, and that clearly is our base here. And then this here would be our lateral face. And as we notice, this figure has lateral faces that are triangular, because it's a pyramid, but its base is also a triangle. So that tells me that this is a triangular pyramid. And so there you have it. We're basically, even though we're going to discuss what a net would look like for a hexagonal pyramid or a pentagonal pyramid, we're not going to really need to construct any nets for those because we won't be finding surface areas of those figures. Although you certainly could, if you wanted to. You'll have the tools to do that. If you could find the area of the base and you can find the area of each of the lateral faces, you clearly could find the surface area of one of those types of pyramids, but it won't be our objective today. So just the key idea page basically just shows you what I showed you with the physical representation. When you take that pyramid, you can unfold it, and that, of course, that base is going to be right in the middle. So when you see that and you compare it to this one here, this is all in lesson 8.3. You're going to see that those nets are very easy, and they've darkened the base to make it even more obvious. I think that the base is going to be in the middle, and then you just need a triangle on outside edges of it. So we're going to do two things right now. We're going to practice drawing a pyramid, and then we're going to practice drawing a net of a pyramid. I'm going to do this kind of free-handed with the use of a ruler to help me out. So first thing I'm going to do is I'm going to make my my base of my triangular pyramid, and I'm just going to make it a triangle. So I'm going to go ahead and use my other pen and this ruler to connect those dots and make my triangle nice and neat. And then, if you'll recall, our steps were that we needed to draw a point above the whole thing, and then we connect all the vertices to that point to make my triangular pyramid. And you can see from my examples the other day compared to my example now, using that ruler does make a much nicer product. Now, again, because of my perspective, when you draw a pyramid like this, you can't really tell whether all these lines are the same because you're looking at it from the side view. But what I'm going to do is I'm going to make this triangle as close to equilateral as I can for my net. And so I'm going to just try to make an equilateral triangle. Remember, an equilateral triangle is a regular polygon. It would have all congruent sides. And again, I'm free drawing this the best I can for the distances to be approximately an equilateral triangle. As you can tell when I drew it, this is a little bit shorter, but it's approximate. Typically an equilateral triangle would have 60-degree angles. You'll notice I didn't get a protractor out, so it's not going to be exact. I am going to use my ruler to make sure that all my faces are the same height. So I'm going to use the ruler and I'm going to measure out, and I'm going to make the height of each point of my triangle to be 1.5 inches. And so that's what that point is going to be. So you can see 1.5 inches right there, and then one more 1.5 inches. And then I'm going to darken those dots for so you can see those a little bit nicer. And then you're going to notice I'm going to go ahead and connect those points to make those my lateral faces. And so when I'm all done, you'll see that I've got a net that could be used to find the surface area of a triangular pyramid. Now keep in mind throughout, if I'm going to find the area of these parts, I need to know how tall the triangle is, and I need to know the base of the triangle. Okay, so for each of these I know how tall they are because, as you remember, I measured them. But if I was to need to find the surface area, I would need all those dimensions, the base and the height of each of those triangles. All right, so let's move on. We're going to do a similar idea, but we're going to use a rectangular pyramid at this time. So again, just like before, I'm going to go ahead and this time I'm going to measure things out, make it a little bit more precise. I'm going to go ahead and make this rectangle. There you go. A 1 inch by 2 inch rectangle. And connect those dots. Go. And I'm going to make this this triangular base. I'm going to make it we'll make it 2.5 inches from the top, or from the base here. So that's where my point will be. And here I go. Connect those dots. I just like to connect the dots with the finer pen so that it not too hard to see the whole thing. So pardon me as I keep switching. And there you go. You can see, again, using that ruler makes for a much nicer, perspective and a nice, neat drawing. Again, remember that whenever we're doing a pyramid, we're going to have lateral faces that are triangular, but then our base names it. This is why this is clearly a rectangular pyramid. Now, just like before, my base is going to be that 1 inch by 2 inch rectangle. And so you can see right here that I'm going to draw those dimensions so I can get my 1 inch by 2 inch rectangle, and then we can draw the triangles from there. Now you'll notice that the heights of my triangles will be the same, but because my rectangle wasn't a square, my triangular faces that'll be on the outside of the left and right here, they're going to be different. So we're going to try our best to get this dimension to be approximately accurate. 2.5, 2.5, 2.5, and just had just enough room to do this. Looking forward to seeing how this turns out. So we're going to connect those dots to make those lateral faces. And you can see those guys. And you'll see if all these measurements were accurate, the opposite lateral faces would be congruent. But not all the lateral faces will be congruent. But you can clearly see how we were able to make that net. And again, you could draw this on cardboard, cut it out. What I did when I created this, I made slight cuts with, you can have a parent help you with a sharp knife to allow the corrugated cardboard to bend nice. Typically cardboard's a little hard to fold straight. But if you had some cardstock, it would look great. And you might practice, building some pyramids. All right, that's all I have for today. Thanks for sticking around until the end.